If we return back to our problem, this was the problem that we had in hand and we are trying to solve it for its simplification of the force and the moment. And what we did previously was summation of all the forces along z direction was coming out equal to minus 500 Newton. This was minus 500 Newton. And then we are trying to calculate the moments. In order to calculate the moments, let me use the vector formulation right now. The moment, summing up all the moments, was coming out equal to the moment because of this 200 Newton force. This 200 Newton meter force, first foremost, you can draw the radius vectors from point O to each of the forces. You can draw the radius vectors from point O to all these forces. Okay, and then we calculate the moment because of this 200 Newton force. This is, you can write this as, this is R cross F, that is 1 meter, that is 1 meter along x-axis, that is 1 meter I cap, this is R, cross F, F is equal to 200 Newton, that is minus 200 Newton K cap. This way of writing the forces is very easy as compared to the previous way of writing, because in that very case you have to find the directions using the right hand screw rule. Here you don't have to use the right hand screw rule because the cross product will directly give you the direction. Okay, so this is R cross F, this is the force of minus 200 Newton force, and this force is acting along, this force of 200 Newton force is acting along K cap, okay, negative z direction. So this is R cross F. Our R is 1 meter I cap and our F is minus 200 K cap. Then we have plus the moment because of this 200 Newton force. This is R. R is again the distance from here to here. Radius vector is 2 meter Y cap. That is 2 meter. That is 2 meter J cap cross the force. As far as the force is concerned, the force is downwards. That will be minus 200 Newton K cap. So that is minus 200 Newton K cap. Okay. And the moment because of this force of 100 Newton, that is equal to plus the force because of this moment because of this 100 Newton will be will be R cross F again. That is R cross F. As far as F is concerned, the force is 100 Newton. That is, since it's along negative z direction, it is minus 100 Newton K cap. Minus 100 Newton K cap. Okay, 100 Newton K cap. So this way of writing the moments is easier as compared to the previous way of writing the moments, because there you have to take the direction every time of R and F. But once you are writing the vector formulation, the cross product between R and F automatically takes into consideration the direction. You need not to find it, the cross product will automatically give you. So that is the total moments, therefore will be the total moments because of all these forces will be, we know this is, if this we treat this to be our I cap, this is J cap, and this is K cap. We know first the moment, it is 1 into 200 minus 200, that is minus 200, that is 200. Unit will be Newton meter, which we'll write later on to all. It is I cross K. As far as I cross K is concerned, you are coming in a cyclic form. I cross K is minus J. So minus minus will be plus. So it will be 200 J cap. Newton meter. Okay. The next one will be 2 meter into 200 Newton, that is 400 Newton meter, which we'll write later on. 400 Newton meter. Then it is J cross K. Now, as you are going from J to K, J cross K, you are going in the cyclic way. J cross K is plus I cap. Plus and minus is minus. So minus I cap. So this is the moment. And then we have the moment. This is 2 meter into 100 Newton. That is 200. This is 200 Newton meter. And we have I cross K. As far as I cross K is concerned, that is minus J. Minus minus will be plus. So this will be plus J cap. Okay. And then we have 2 meter multiplied by 100. That is 200 Newton meter. 200 Newton meter. Then it's j cross k. Again, j cross k is plus I, plus and minus is minus, so minus I cap. And the total unit for all this, total units are Newton meter. Okay, this is Newton meter. So if we try to find out the total moments because of all these forces will be minus 400 minus 200, that is minus 600 I cap. And so we have minus 400 I cap minus this, and we have 200 J cap and plus 200 J cap, that is plus 400 J cap. So this is plus 400 J cap. So this is 400 J cap Newton meter is the total moment. Now, who is producing this much moment? This moment is produced by these all forces. Okay, so at point O, the indication that we have, we can replace all these forces at point O. At point O, we can replace all these forces by a single force having magnitude of 500 Newton. Okay, having magnitude of 500 Newton. Okay, and having moment equal to 600 I cap, and having moment of 600 I cap, that is along x-axis, it is having a moment of 600 Newton meter, and along j cap it's having a unit of 400 Newton meter. So this is one way of writing it. So you at point O, you can replace all these forces by a single force of 500 Newton meter along minus z axis, and a moment of having a magnitude of 600 I cap will be in the opposite direction. Having 600 I cap will be in this direction, having a magnitude of moment 600 I cap along this direction, and along y-axis is having a moment of 400. This is one way. But I mean to say, the further simplification is reducing this force and these two moments by a single force. For that purpose, what we will do, we will say, let's suppose that this force is of 500 Newton is not acting at point O. Let's suppose it's acting somewhere else. Let's suppose that this force of 500 Newton is not acting at point O. Let's suppose it's acting somewhere here. Okay, where its coordinates are, let's suppose it's acting somewhere here, where its coordinates are equal to, where its coordinates are, along x-axis, let's say its coordinate is x, along y-axis, let's say its coordinate is y. We say that, let's suppose its x and y coordinates are, let's suppose its x and y coordinates are x comma y. Let's suppose this force is acting here. This force of 500 Newton along minus z direction is acting in such a way at a point, okay, having coordinates x comma y, that is this distance is x and this distance is y. This is acting in such a way that at point O, it is producing the same moment as a moment of 600 I cap minus and plus 400 J cap. It means how much is the moment of this force of 500 Newton acting at a point having coordinates x comma y, about an x is passing through point O. The moment of this 500 Newton force should be same as this much, as this moment. That means calculate the moment of this 500 Newton force. 500 Newton force, the moment of 500 Newton force will be now calculated as, draw the radius vector. This radius vector cross F, that is the moment of this 500 Newton force will be R cross F, that is R is equal, it is X component, it will be Xi cap plus Yj cap, this is R, and its cross product with a force of 500 Newton minus 500 Newton, that is minus 500 Newton. Okay, force of minus 500 Newton. Okay, this is these units, this x is in meter, y is in meter, therefore it will be Newton meter. This is R cross F. Okay, this is R cross F. This is the moment of this 500 Newton force about an x is passing through point O. This moment is equal to, this is 500 Newton meter, 500 Newton. This is force of 500 Newton and it's acting along k cap. Okay, minus k cap. So the magnitude of this force is x into 500, that is 500x, unit is Newton meter, and 500x, this is I cross k. I cross k is minus j, minus minus is plus. So it is 500k j cap. The second is y into 500, that is 500y, that is 500y. And it is j cross k. As far as j cross k is concerned, that is I. J cross k is I cap. Okay, since this is minus, it will be minus here as well. This is the magnitude, this is the moment which is produced by, which can also be written as, this can be written as minus 500 I cap minus 500 y I cap minus 500 y I cap minus 500 y I cap plus 500x j cap plus 500x j cap. This is the moment which is produced by a force of 500 Newton about point O. Now 500 Newton force, when it has been positioned at a coordinate x comma y, it should produce the same moment as the moment which was already present at point O. That moment was equal to this much. Okay. Therefore, if we balance the two, let me do it here. That is 500 minus 500 minus 500 y I cap plus 500x j cap plus 500x j cap is equal to minus 600 I cap minus 600 I cap plus 400 j cap. Since these two vectors will be equal when their individual components will be same, equating the components of xi on the right hand side should be equal to the components of I cap on the left hand side. That is minus 500 minus 500y should be equal to minus 600. Balance the x and y components should be equal to minus 600. Therefore, y comes out equal to 600 by 500. 600 by 500 is equal to 600 by 500 is equal to 1.2. Since we are taking distance in meters, it will be 1.2 meters. The value of y should be 1.2 meters. Balancing the j components, it is 500x should be equal 500x should be equal 400. Okay, therefore the value of x comes out equal 400 by 500, that is 0.8 meter. So our problem is reduced. The problem reduction means that as far as this plate is concerned, on this plate we are having lots of forces acting. Okay, on this plate we are having forces 200 Newton, 100 Newton, 200 Newton acting. Okay, we can replace all these forces. You need not to write this force here. Okay, you need not to write this force here. You need not to write this force here. Okay, select a point whose coordinates is x is equal to 0.8, move 0.8 distance along x-axis and move 1.2 meter along y-axis. Along x-axis you move to a distance of 0.8, that is somewhere here. Along y, then you have to move to a distance of 1.2. 1 point will be somewhere here, that is at this very point. Go to this location. Okay, having x comma y whose coordinates will be 0.8, whose x coordinate is 0.8 and y coordinate is 1.2 meter. At this very point you draw a force. At this point draw a force along of minus 500 Newton. Draw a force of, write a force of minus 500 Newton, right? Apply a force of 500 Newton, and this force is to be applied in negative z direction. The force, this force of 500 Newton acting at a position 0.8 at 1.2 meter coordinates will have the same effect as these forces individually will have. So we can replace all these forces by, not by a single force and a single moment, but by a single force that is acting at a position 0.8 comma 1.2. This is called the further simplification of force system resultants. Okay, in the same way you can talk about, you can solve these questions in the same way, and you can have a look hands-on these problems yourself. Okay, so try to solve as many problems as you can. If you have some problems, you can consult me, you can mail me, you can let me know through message your problems so that we can solve them. In the next coming lectures, we'll be talking about more on the reduction of distributed loading, and we'll be taking the concept of centroid. Okay, thank you.